Good morning, advanced algebra students. We are going to start the second part of the 2.1 notes right now. The first part, 2.1a, was on slope. The second part, 2.1b, is on slope-intercept form. Slope-intercept form. So just go ahead and put that at the top of your notes. And then we need to write down what the slope-intercept form is. The slope-intercept form is y equals mx plus b. Y equals mx plus b. So hopefully you know what the m is because we just did that. The m is our slope. The b is the y-intercept. Y-intercept. Now we're going to go over how do you graph lines in this format as well as how do you write equations of lines in this format. The cool thing is that graphing is so easy. We begin at the b. So what I like to do is write the word begin over the letter b, and then we move according to the slope. So I write the word move over the m. Now, when we're graphing a line that is in slope-intercept form, we just use the two numbers that we have to do the graphing, and it takes less than 30 seconds. So let's do example 1, y equals 1/2 x plus 1. Notice that the y-intercept is 1, and that is where we begin. So I would go on my graph to y is 1 and put a dot. We begin at the y-intercept. Then we move according to the slope. Since the slope in this case is 1/2, we would go up 1 and over 2. Up 1 and over 2, and then draw a line between those 2 points, and that would be the equation of our line. So graphing in slope-intercept form is super easy. Now, the only thing that you might have to do is if the line is not already in slope-intercept form. So let's say, for example, 2, we have 4y equals x minus 12. 4y equals x minus 12. That is not in slope-intercept form because in slope-intercept form, the y is on its own. It says y equals. So what would I have to do to this equation to make the y be on its own? I would need to divide by 4. Now we can't play favorites, you have to divide everywhere. When you do, you get y equals 1/4 x minus 3. So let's go ahead and plot that. Now that it's in slope-intercept form, we're going to begin at the b, so begin at -3, and then we're going to go up 1 and over 4. Up 1 and over 4, and graph that line. So it's a very, very straightforward process to graph lines in slope-intercept form. Now, writing equations in slope-intercept form is also relatively straightforward. We still need to know that we need an m and a b. So every single time you're asked to graph an equation in slope-intercept form, you should tell yourself that you need to 1, find the m, 2, find the b. Find the m, find the b. It's going to be the same thing each time. Now, how we do that might change a little bit, but what we need is exactly the same. We need the m and the b. So let's do our first example. This would be example number 3. How we could write an equation of a line in slope-intercept form that is already graphed for us. So let's draw a line that goes through the y-axis at the point 0, 3, and also contains the point 3, 2. All right, so we want to find the m, find the b. To find the m, we're just going to count out the slope. We can see that we need to go down 1, so that way b minus 1, and then we need to go to the right 3, which would be positive 3. So our m is -1/3, which makes sense because this line is going downhill. Now, to find the b, we just look at where does the line cross the y-axis. It crosses at 3. So our b is 3. And then our equation becomes y equals -1/3 x plus 3. So you're just finding the m, finding the b. No matter what it is that you're working with, that is your goal. Let's do another example. Let's call this example number 4. Let's write an equation from 2 points. Let's go ahead and use the points -1, -2, and 1, 6. So -1, -2, and 1, 6. What are the two steps? The two steps are to find the m, find the b. So let's find the m. Let's do the slope formula. We'd have 6 minus -2 over 1 minus -1, or 8 over 2, which is 4. We have found the m. So when you need to find the slope, just do the slope formula. Now, finding the b just requires an extra step. We know that all of this information needs to fit into the format y equals mx plus b. So my strategy is going to be to use everything that I have so far and plug it into the equation to find the b. So I know, and I'll circle this in red, that my slope is 4. And I know I also have a point on the line where x is 1 and y is 6. So I'm going to plug in the m, the x, and the y and solve for b. So if I plug in for y, I get 6 equals, and then m is 4, and x is 1. So 6 equals 4 plus b, or b equals 2. So now that I have my m and my b, I just write my equation. Y equals 4x plus 2. All right, now, I think that's it. I think I'll do one word problem just because that went fairly fast, and I know that this does come up on your homework. So let's just do one word problem because I think we have the time. So this will be example number 5. Of course, I can't resist because it has a motorcycle in it. Madeline will ride her motorcycle at a rate of 55 miles per hour. If she has a 120-mile ride ahead of her, write a linear equation to represent the distance Madeline still has to ride after X hours. What does the y-intercept represent? Okay, well let's look at this. It says write a linear equation to represent the distance Madeline still has to ride after X hours. So they've told us what they want X to be. So this will be example number 5, and X is the number of hours. And Y is the distance she still has to ride. Distance left to ride. Okay, so let's think about this for a little bit. If we want to represent the distance that she has left to ride, we need to understand that distance is rate times time. So let's write that down. Distance equals rate times time. And it says here that she's riding 55 miles an hour. So if we want to know how many miles she's already covered, what would be the algebra expression for that? If she's riding 55 miles an hour. The algebra expression to represent the distance she's ridden would be rate times time, or 55x. However, if we're looking at for the time she has left to ride, what we want to do is write y equals negative 55x, because we want to subtract that off out of 120. So y equals negative 55x plus 120. What this part of the equation tells us is that she has 55 less miles to ride for every hour she's been on the bike. And then it says, what is the y-intercept? The y-intercept here is 120. And basically what it represents in this case is the distance she has left to ride at the beginning of her ride. So when x is 0, when time is 0, her mileage left is 120. So that's our last example. I look forward to seeing you in class. Thanks, guys. Bye.